if I take these probes and I touch them together, they short out. So essentially this oscilloscope is in XY mode and it has a curve tracer with 7 volts across it at the moment. So what I'm going to do is I'm going to balance I'm going to check these two devices against each other. So this is a known good switch mode power supply, and this is the suspect switch mode power supply. So what's happening here is I'm going to test certain areas, and we're going to look to see if the curve tracer agrees, if the circuits agree with each other. So one of the suspect things are these MOSFETs here. So let's take a look at the good one first. I'm going to put the center on the red probe on the center and go here. We see that it looks somewhat like a chair there, right? So we'll do the same thing here for the other side. So those look pretty good. Now let's go to my suspect device. Looks the same. And looks the same. So that's good. So let's go to the opposite side. So I'm going to again put my red probe in the center. And to the right, it looks like we have a short. If I reverse them, let's see what kind of Lissajous pattern we get there. Also looks like a short. So should look like a short all the way through. Okay, let's look at the good device. Yes. So if you have one of these and you're wondering, is your device good, you can check it against this video actually and take a look to see any differences. We won't go through everything, but we'll go through some obvious things. So for instance, if I went from the two outsides, we get that chair pattern again. And I'll do the same thing all the way down. This is the suspect one. This is the good device. Looks the same. Looks the same. All right, so we know the MOSFETs agree. They look the same, right? So moving on, another thing that can be suspect are these NPN and PNP transistors. So let's look at the good device. And that looks like that. And then that's the NPN, I believe. But doesn't really matter because that's going to be the curve, the signature. If I put the positive on the center lead of the transistor and the negative on the left side. And then I'll do the same thing over here. We should get a similar result. And we do. An odd looking chair, right? In a sense. Let's go to the opposite side. And it looks a little bit better. And we'll come back over here and compare that. It still looks good. So as long as they look the same, right? So I could reverse the leads there. And take note that we get the same pattern just in reverse, right? So I'll do the same thing on the opposite side. Do the same thing here. The same pattern is just upside down. So the leads don't really matter. So here we're going to go here. And we get that pattern. I'll do the same thing on the other side. We get that pattern. Then I'll go here. We get that pattern. And then I'll go here. We get that pattern. So they agree that they look the same, right? So let's look at this set of transistors here. This was one area of concern to me. So I'm going to put my red on the base there. And that looks like that. And then I'll do the same, or sorry, here. There we go. And then I'll do the same thing here. Again, if you're following along, you can see and compare your device with what I'm doing here if you have a curve tracer. So those look the same. For my positive here on this one. And that's a funky looking Lissajous pattern. Let's do the same thing over here. So I'm on Q3 at the moment. Same thing, right? Go to the other leg. Now it looks like that. Come back to this one. Same thing. So they're identical. So that should be the pattern if you're looking at Q2 and Q3. Let's look at Q1. All right. Same thing. Other leg. Looks like a Not quite as short, a little elliptical there. Must be a cap somewhere in there. Let's see if we can see that same thing. Yeah, just see it barely split apart. Okay, so that looks the same. So let's take a look at the IC now. So if I put the my positive on pin 5 and I go to pin 1, we look like that. I'll do the same thing here. Positive on pin 5, pin 1. All right, then we'll go down to pin 2. Okay, pin 2 looks the same. Pin 3. Oh, maybe I'm not making connection. All right, there's pin 3. Pin 3. Yep. Pin 4. That looks interesting. Pin 4. Just as interesting, but it's the same, so that's good. All right, now I'm going to be on 5 here, and I'm going to go to pin 8. That's what pin 8 looks like on the good device, the suspect device, pin 8. Oh, same thing, great. Pin 7. Looks good. Pin 7. Same thing, and then finally pin 6 and 5. There it is. And pin 6 and 5. There it is. So again, if you have this device, you can check directly along with this video. Let's look at the opto isolator. So I'll come across these. Now this is a 6 pin, but only 4 pins are active. So that looks good on that side. Looks good on that side. Now, of course, we know I replaced that one. Let's look at the opposing side. A little bit of an angle, well, 45-degree angle, and then a little bit of a space between, almost an elliptical there, right? Let's see if we have that element here. We do. Looks good to go. All right, so let's move on. Let's check this array of transistors here. Let's go to Q10. Looks like that. Other side. Looks like that. Let's go to Q10. That's the same. Q10. That's the same. All right. Let's go to Q9. All right. Q9. There it is. Fumbling with my... Yeah, that looks the same. All right, let's go Q14. Looks like that. On the right side, left side, looks like that. Fine. Q14. Come on. There it is. Perfect. Q16. Interesting. All right. Q16. Right side. Yep, left side. You can see that residue pattern start to move. That's a cap charging. Q15. See that movement there? Q15. Let's go to the left side of Q15. Looks like that. Left side of Q15. Looks like that. Well, is that the same left side of Q15? Left side of Q15. Yeah, looks good. All right. Let's go to Q13. Left side of Q13. Q13. Left side of Q13. Looking real good. Almost done here. I think that's Q1. Looks like that. Right side, left side. Well, there's an residue pattern for you. Hopefully we got the same thing here. Right side. Yeah, left side. Wow, look at that. Okay, perfect. All right, so that's really about all we can check. We could spot check a few caps, but so for instance, this is C30. Looks like that here. Let's go to C30 here. Same thing. Let's look at this diode. Looks like that. This diode. Looks like that. We could check it reversed. You're going to get the same pattern, just upside down. So it's not like when you're checking with a multimeter, you get one one volt is one way and one not the other, right? So this is putting an AC volt across the device under test here. So I think that about covers that portion. Let's look at these two diodes here, diode 2 and diode 3. So D2, right side, looks like a short. D2, left side shouldn't have anything because that device doesn't have anything. D3 looks like a little bit of a short, but not quite 100%. So D2, that's definitely looks like a short, but it's not a short. It's just the way that looks. D2, and it's in a little bit of an angle there, and then, yeah, so that looks good. So that is this side. Let's flip the boards over now, just for the moment, so we can have some more access. And let's look at the primary here. Looks like a short. Looks like a short. But it's actually not a short. It just appears that way with this test. So this should be interesting. Let's go here. Let's see. Yeah, there it is. Okay. So see that pattern? Go down. You see that pattern on all of these. That's that cap and diode loads on the opposite side. That looks good. And here should be a circle. Yeah, there's a big circle there. Circle, circle, and circle, circle, circle. Great. All right, so those transformers are fine. We really can't check these caps and diodes. They will just look like shorts. I'll show you what I mean. So yeah, going to kind of waste our time there. But you should test them for actual short with a digital multimeter. Oh, let me remember. Is 3 ground, I think? All right, so if we go from center to the outside, that looks like a ground, and then center to the 4th pin looks like that. Let's go here. Center to the outside. Okay, center to this pin. Looks the same. Then let's go back to center to this pin here. Looks like a short. Pin 1 looks like a short. They look like shorts. I'd really have to get out I guess that's the only pin you can really check there is pin 4. Pin 4 to pin 1. Pin 4 to pin 1. Again, you can see the pattern moving as the cap charges in the circuit. So that looks as good as it's going to get. Oh yeah, we got these two diodes here. So here's a diode, D10. And you can see there's a cap across that, obviously. So there's only the left leg on this D10 is active. The right side there's no device in it. So let's do the same thing on my device and see. Ah, there it is. Let's go to D13, snuggled way down inside here. And looks like a very tight elliptical, and same thing. All right. Looking best that can be. Let's see. Okay, so that is really about all that we can do for this particular device. Now, if there are areas that have certain caps on them, and you can find a larger span of circuitry. So, for instance, if I went from here to here, you see that pattern right there? So I'm on the first leg of the, let me get back in the camera. I'm on the first leg of the optocoupler here. And then I'm on the right leg of D16. And I just get that pattern. It's a random pattern, right? So if I wanted to check that entire chain, that's what it looks the same. So you can make up any test that you want. We could say the second side of the elliptical to R45. We get this, or R48 rather. Let's check mine. Second side of the optocoupler rather. To the right side, there. Same thing. So it's just one way of verifying I'm just making things up as I go. It matters and it doesn't. But you can look at the schematic, and you can go across a whole array of devices and get some kind of reading if you needed, if you wanted to check a point A to point B kind of thing. So let's see, pin 4 to the opposite side of C20 looks like that. Pin 4 to the opposite side of C20 looks like that. So you can spend a good amount of time, but once you've worked on these for a little while, you get a feeling for what are the most important things to check. And again, there's no electricity on this device. All the caps have been discharged. So what we're doing is we're just simply testing the base electrical values and how they have some influence on AC. And that's really what's happening. So we're not necessarily, turning the devices on per se and seeing them in their full action as you would with an oscilloscope and, these plugged in and electricity running through them, and very carefully knowing where to look and what you're looking for in a safe fashion. This is a way to just verify one good known device that we know is working properly to another one, trying to look for any anomalies that we might not have been able to discover with a digital multimeter. And that'll give us a sense of where to look further. So that's it for this. I think, one other thing we should check is this cap right here. Let's take a look at that. And that cap, which you'll probably be able to see it charging now. So that's here. Let's look at that one time. See it charging? Looks like that. And proper. Looks good. And I guess we could check the bridge rectifier. Let's go. Let's see. I forgot. Lost track now. So this is the good one on the left and the suspect one on the right. So let's see. Let's choose these two here. Looks like that. We'll go to this one. Same thing. Go to the center two. Same thing. Center two. Same thing. These two should be. Yeah. All right. So, yeah, those are good. Wonderful. So, as it stands right now, it looks like me replacing these two. Let's see which one. This is the one. Me replacing these two resistors right here and these two diodes has fixed this switch mode power supply on the surface. We'll bring it up with a variac, and we'll slowly get it to turn on and make sure that this IC is getting enough power, and we'll check it another way to be certain. And then if we have succeeded, then I'll change these caps once again and get something more stable in there that I can actually lock down with non-acidic silicone and get this line 6 back up and running. All right, so if you remember where all this goes, so this guy has to go on, and then this white cable goes here. And then goes here. And this guy goes here. And that's good, that's good, that's good, that's good. All good. All right, so I'm going to just take a roll of solder here and put that back behind here. And put these two guys on. This is our power switch. Alright. I'm going to put this ribbon on. And this guy on. still posing a little problem back here. There we go. And I'm going to scoot it all forward because I have to make room for the most important element here. And that is a proper load resistor. This is an 8 ohm 100 watt. It could be done better here than this, but it's in progress. I'm building a dummy load at the moment. Oh, it's going to go left mono, 8 ohms. Let's think about what we've done before I hit that switch. So, this is the new switch mode power supply, even though we've already rebuilt this one successfully. Just as a cautionary tale, I'm firing this up. We're just going to put this one in just to be sure. And we fully 100% rebuilt the output section. Both ICs, all the caps, resistors, even one of the resistor arrays in there. But all the large items that were suspect have been replaced. And here we go. Let's see if it still has that symptom or if we get that proper LED. Look at that. She's glowing properly. No more blinking. Looks solid and stable for the moment. We won't know until we fully put it back together and plug it in and take a listen to it. But so far, so good. And like any good service job, if you're the technician and you're inside, you might as well clean the pots so you can spray them from here and here. And I like to use this particular product. Not endorsed by them, but just a product I like. At any rate, spray all the pots, clean those, and then we'll also burnish the jacks. Of course, when cleaning the jacks, get the external dust off. And then if an amp's been sitting a long time, like this one that has been needing repair, you might want to burnish the jacks. And what I mean by that is just use this little tool like this, and I put a squirt of CRC contact cleaner on there. Try to do this with one hand, and just put a little squirt on there. You could squirt into the jack, but I don't prefer to do that. And then just turn it. I give her a good 5 or 6 turns either direction, and that's really all you need. And believe it or not, the jack itself, being having a cable go in and out, will clean it as well to a certain extent. But this goes in a direction that it wouldn't normally go, so it helps to clean those contact points. All right, so this amp has been on for the past many hours, probably 3 hours, I guess. So let's take a look and see what we get. Just put everything at 12 o'clock except for the reverb. So this particular amp has 2 amps built in a sense. So this set up here and then this set down here. At the moment you can see that both of these LEDs are turned on, but only this amp is active. So that's going to be the clean. I have to keep this volume down, my neighbors. All right, so that's the clean, and let's just get a good sound. Make these basically the same. That's a good starting place. So this is the clean. Sounds pretty good. Class A30. The Plexi lead. Brit 800. And solo. Explorer. Some of these will be different in volume depending on how Line 6 modeled this. You can see like the master down pretty much. So but for this particular patch Explorer, a little bit quieter. Tweed 410, blackface, and then amp 2 starts with rectified. Zen Master, small tweed, blackface 212, modern class A, class A15, plexi 45, and highway 100. So if you wanted to say turn 2 amps on at the same time, let's say I wanted a blackface, whatever we're on, you would just click the LED in the same direction as the other one and would turn both on. So as you can see now, both of those amps are active. Additionally, you have the ability to blend or split them, and that has to do with the output of the amplifier. And then you have these 4 buttons up here, which are presets that you can utilize to make some sort of combination here and settings with all of your basic knobs. So somebody prior to me I'm not sure if these are factory or not. They might be, or maybe somebody has set their settings, but fortunately in this repair none of the settings were lost. So let's go to A. First off, we'll do this. I'll just go back and show you what it does. So when it's on A, or sorry, when there's nothing turned on, you choose what you want it to be, whatever. And then when you choose A, you can see whoever set it both to blackface and blackface 212. Both amps are on, and they got it split here. B is class A30, class A15. These might be factory. C is plexi lead and plexi 45. And then D is line 6 clean and rectified. Ooh. I guess that's kind of like a wet dry rig. That's how I run my rig, wet dry. So that's neat that this head can do that. Doesn't sound bad. To make sure, like all amplifiers, tube or solid state, it's imperative that you match the output impedance with the cabinet. So if you have an 8 ohm cabinet or it has different configurations, you need to know what the ohms are, if it's 8 ohm or 4 ohm, because this can only do 4 or 8. It'll do a 16, but with a specific wiring, and that's all in the manual. So so make sure to read your manual when you're dealing with an amp like this, or any amp really. Make sure that you're educated, because that's my belief is how this amp went, is the impedance was mismatched, and or it was at a top volume. Somebody pulled out the output and maybe shorted the output section. They could have pulled out the speaker cable, or they could have had a speaker that fused itself, the coil fused and became a short and then blew the output. So many different ways to blow a solid state output section of an amplifier. At any rate, now something to notice here, I mentioned about turning this master down when you're turning the amp on or off. That's because a lot of solid state amps, not all, some contain circuitry to give you a quiet shut off, and some pop the speakers. This is one of those models that pop the speakers. So listen. Can you hear that little bit of pop there? So some models have that, some models don't when it comes to solid state. So this is one of those that do so as a best practice. Just turn your master down. And you know, if you really wanted to be, I don't know that it would make much difference, but let's try this. All right, it was fairly quiet. We'll give it a second to kind of juice up here. Turn down your volumes, reverb, your master, turn everything down, and let's see. A little bit quieter, but not much. Let's see if it makes a difference here. I'll give that time to settle off. See if it makes a difference when we go, we'll say halfway here. Turn on some reverb, turn the master up a little bit. All right, and I'll turn my guitar down. No, so same thing, but it's just part of the design, so don't let that get you concerned. It's good to go.